Now in part 2, we'll take a look at how to use the serial.read function. The read function is used to receive information. Right? So it's going to read any incoming serial data. Right? We call it a serial.read. We don't pass any information to it, so parameters none means we put no arguments in between the parentheses. And it's going to return the first byte of incoming serial data available. Right? It returns that byte as an integer data type. And if there's no data available, it returns a -1. So let's just look at an Arduino program. All right. So all I've got in here so far is the comment part 2, illustrate how the serial.read function works. Remember, whenever we work with the serial port, we have to call serial.begin, and we'll give it a baud rate. We'll use its default configuration of 8 data bits, 1 start bit, 1 stop bit. Right. And we saw in part 1, if we want to then echo out some information, transmit information, we use serial.print or println. So here then, we want to read the information. So let's then, let's create a variable to store that in. We can create a global variable. So if I then call this maybe variable read byte. And here, if I say, well, what I want to assign to read byte is the information that the function serial.read returns. Right. And then if we were to upload this sketch, right, this would probably be reading in some information if it's available, or it would get a -1. So remember, this function returns a -1 when no data is available. Well, let's echo. So echo means to print back out. Echo, print out the information received. The information received is the information read. So if I say serial.print read byte and serial.println, and then print out what's stored in the variable read byte. And let's just go ahead and let's put a brief delay on here. And let's see, looks like I'm on COM4. I've got my Arduino Mega. I'm just going to go ahead and upload that. And save it as saving it on my desktop as Arduino Serial part 2. All right, it's uploaded. Let's run the serial monitor now. And so we can see now we're consistently getting this value of -1 for read byte because we're not actually reading in any information. In order to read in that information, we can actually then type things here in the send field. See where the flashing cursor is? If I want to type something in, so I'm going to type an A, and I can hit the enter key or I can hit the send button. And now notice this 97 that popped up. What I did here is I transmitted one piece of information, A, hit the enter key. And if we go ahead and we were to bring up the ASCII table, right, we just pop up this ASCII table here. Right. That's a lowercase a is a decimal 97. Right. That's what we're seeing here. Now notice just 1, so if there's just 1 there and I hit the enter key, we get that 1. If I type A, hit the enter key, we read the first character A, the second character A. Once we read something out of the buffer, it's gone. So once we call serial.read and store that in read byte, that information's been pulled out of that receive buffer and it's not available to be read again. So if I type A, hit the enter key, we get that single 97. Right. AB, we're going to get a 97, then a 98 for the B. Right. So notice what we're seeing is the ASCII base 10 value because by default, this then gives us the decimal value. And that represents the character A. Otherwise, we're getting this -1 all the time. Right, this -1 gets a little bit tedious to deal with, because if you think about your program, if you're trying to read in some information, right, and you're constantly reading this -1, you need to know whether or not you've read in good information. Right? You might say, well, I could write some sort of if statement that says I can check to see if read bytes equal to -1. I know it's bad data, otherwise go ahead and process the data. Unless, of course, the information you're reading in at some point, now a single byte probably might not be -1, but that's not the best way to deal with that. Right, let's go ahead and take a look at some of the different serial library functions. Right, so the read function, this is the reference page. So I went to arduino.cc, right? You can go to the reference. This is just the main reference for serial. Right, if we take a look here at the read function, we pop this up. This is very similar to what I had on that PowerPoint slide. It's going to read incoming serial data, right? We call serial.read. If you're working on the Mega, simply because the Mega has 4 serial ports, you can call it, if you're wired into the others, you can call these functions for the others. Right, we won't worry about that. Here's an example sketch then of what we can print out. This is very similar to what we just wrote. But notice here in this example, there is a function called serial.available, right? That is very good to use to avoid getting that -1. So this returns the first byte of incoming serial data available, or -1 if no data is available. We want to call the serial.available function. Right? Just go back to that serial reference, and let's look at available. What available tells us is when we call the available function, it gets the number of bytes or characters available for reading from the serial port, right? That means this is data that's already arrived and stored in the serial receive buffer. So the serial receive buffer can hold up to 64 bytes. And that then tells us the number of bytes available to read. And that's what we want to do. We only want to read when that information is available. Let's then go back to our sketch. And I'm going to get rid of this comment right here. And we're going to say if serial.available is greater than 0, right? And this says only read when bytes have been received. And now we can call read byte. And now only let's print something out when we receive it as well. And then we don't even need this delay, right? We're only going to read information. If we're controlling what we're typing in, we can control the rate we're typing it in. Let's upload this. So now notice we're not getting any output because we're only printing out, we're only transmitting. Remember, print is transmit whenever we receive something. And if we're not receiving anything, then we won't be transmitting. So now if I type that small case A and hit the enter key or the send key, and where did our read byte go? Seems like that didn't transmit before. Let me just restart the serial monitor. Whenever I do that, it's going to restart the program from the beginning. Look at A and the enter key. There it comes. Not quite sure why they didn't show up the first time. All right, so we saw the A was 97. If I type AA, right, there's both A's in there. You press send, but nothing was sent. Should you select a line ending? No, I don't really want any line ending. All right, again, A and the enter key. This is a new message I've not seen before in Arduino. Part of what I was going to show you anyway, we deal with when we send the line ending. Let's just close this down and restart it. All right. So now, if we change this from no line ending to new line, and now if we type the small case A and hit send, notice 2 bytes get sent. The A is the 97, and then the new line character is the 10. If we change this from new line to carriage return, I'm going to type the small case A, hit send. Notice we get the A, and then we get the 13 for the carriage return, which is a \R. If we were to pop open our ASCII table again, right, and we look at the decimal 13, that's a carriage return. Decimal 10 is the new line feed. Right. And if we said both new line feed and carriage return, right, so here's the A, hit the enter key. Notice now we get 2 characters. This can come in really handy for when you're transmitting multiple bytes. If you want to let your program know that perhaps the new line character or the carriage return signifies end of transmission, then you want to go ahead and make sure you append things. But if you're not using anything to signify end of transmission, so I set this back to new line ending. If I just type the small case A, hit the send key, right, now we just get the A in this case. All right, so those are the differences then between no line ending, new line, carriage return, and new line. Right, now let's take a look at what happens when we type in numeric data. Right, so I'm going to now type then the number 1. And I'm going to hit the enter key. And what do we read in other than a 49? If we pop open the ASCII table, let's go to decimal 49. That's the representation of the number 1. Right? And so let's go through these range of numbers. We're going to see that when we type in a 0, we'll get a 48. A 2, we'll get a 50. So here, let me just pop open this again. Let's minimize this so we can then see our program. Right. Yeah, actually, let's restart. I'm going to clear that out. No line ending. I'm going to type 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hit the enter key. Notice each one of those characters is read separately. That first 0 is a 48. There's the 1, 2, 3, 4, 5, 6, 7, 8, 9. But when this, what you need to remember about read, when you use the read function, it treats the data read in as single characters, and it gives you that ASCII value. What we want to do is we want to then think about how we can convert these to numeric characters. But for right now, this is the end of this segment then, just showing you how to use serial.read. The important thing we learned is if we don't have the serial.available, if we're not checking for that, read byte's always returning a -1. Right? You're always going to want to use the serial.available function. You're going to want to call that and say if there's information available. So we check for greater than 0. Remember, this then returns the number of bytes that have been read. This will actually read 1 byte at a time. Store that in our character read byte. It will echo that back out. Now, we could change this to while serial.available is greater than 0, and it would just stay in this loop as long as there was information. Since this is the only thing we're doing in this loop, this looping function, right? This is having the same effect here with the if. It's reading this 1 at a time. So either one of those ways we could use to write this would be correct. The other important lesson here is to remember that this treats everything as that ASCII data. Right? So if you type in the letter A, right, you get a 97. If you type in a 4, you get a 52. If you type in a 4 and then change this no line ending to new line, you're going to transmit 2 characters. You're going to transmit both the 4 and then the new line character of 10. So you need to be aware of what all your settings are when you transmit information, because you're going to have to handle that appropriately when you read it in. Right. All right. Next video then we'll actually cover how to then take these characters that are numeric and turn them into numbers.